kul att se att det är så många som är taggade på AI. Välkomna till det här kunskapsspåret. Hallå? Om artificiell intelligens. Vi ska höra 3 personer idag prata om det här superheta ämnet, men innan vi börjar prata om de här roliga sakerna så tänkte vi gå igenom lite hållningsregler. Mellan de här 3 talarna så kommer vi ha 5 minuters paus där ni antingen kan gå ut och sträcka ut på benen eller välja att gå till några av de andra sessionerna som pågår här bredvid. Men det här är såklart roligt och jag förutom det, om ni har några frågor på några av de här talarnas presentationer så vänta med dem till efter, så tar de någon tid sen. Men då ska vi börja prata mer om vad vi ska se idag. Jag heter Elena Galli och är moderator idag. När jag inte står här så är jag redaktör på bland annat M3, en av IDGs konsumentsajter. Men nu ska vi alltså prata om AI. Det är ju kanske ett av de mest heta begreppen på teknikmarknaden just nu. Jag tror inte jag har sett en lansering av någon produkt eller tjänst de senaste månaderna där man inte pratar om AI. Men frågan är om de faktiskt kan lösa alla problem vi har. Här får vi prata lite mer om de begränsningar som artificiell intelligens har är Amir Rahnama, data scientist at IT.
My name is Amir. I work at IT Solutions. We're like an innovation lab company. And today I'm going to talk about AI in general, a lot of tips, a lot of technical stuff. Actually, this picture, I uploaded it by mistake. I was about to put some other picture. But this is actually pretty much AI. So I was like, why not? Just keep it so we talk about it. Yeah. And these are my colleagues, Joanna, Mikael, Sebastian, and Matthias. We actually have an office in Gothenburg. We're just outside, so please come talk to us about AI or in general innovation. I don't know if I'm going to fall down. This is a very famous picture. It's called Hierarchy of Data Science. And we worked with this idea pretty much a lot. If you look it down, it's more like the data generator, sensors, or user-generated content. And if you come up, you see data flows, and then you see like cleaning and pipes, and then on top of the hierarchy, you see more analytical things. So today I will talk a lot about analytical things because I have a very technical background, but I'm trying to talk about intuition so people actually can understand, so not too much math. Right? So let's start by analytics, features, and training data. Brandon Rohr at Microsoft has this amazing blog post about data science and what can data science do for you. And he puts 5 constraints on what, like, when you actually can optimally use this data science. He starts by the first constraint. Your question needs to be short. And this is something very important because when people talk with the general purpose technology of AI, they feel like they can ask whatever question there is and something will come up, but that's not the case. Actually, in most cases, when you ask a question from an AI algorithm or machine learning algorithm, the response should be either a number or a label. And that actually boils it down to a very narrow set of questions that AI can answer. The second is actually your data measures what you care about. If you want to know why is it that your customers are leaving you and you feed them data about their shoe size, then you're going to get analytics on their shoe size. You're not going to find out the real reason why they've left you. And then the third is actually an accurate data. So the data needs to be accurate, and this is something we see every day with our organizations, that the data is not accurate, unfortunately. And we have another curse in all organizations, I think, is that you have a lot of missing data. Like, oh, we forgot to log this data, or we forgot to add this data. So you have a lot of holes, like Swiss cheese in the data. And that actually constrains the way we do analytics on data. And the last one is that the assumption is always that you have a lot of data. And that lot is not really descriptive, but it actually, you need a lot of data, for real. What do we see in general in organizations is that the data is growing. And that's what all companies tell you, that our data is growing. But the problem is that they're not really cleaning the data. So you get a lot of noise inside. And that's a very big problem when you start analyzing the data. The other problem is that it's not usually validated, or if it's validated by people. And that's very limiting, because people also make mistakes and add bias in the data. And this thing we mentioned, that it's not really connected. You have a lot of missing values in the data, and that's actually not in favor of AI algorithms or machine learning algorithms. One bigger problem is that the data is not aggregated. So two departments working for the same company have two different data types and two different formats, and they don't add up to each other. And if you run around in departments saying, why doesn't the sale doesn't really match from this department and that department, there's a lot of manual processes that people can't really explain. It's not structured. Every department in big organizations, they store the data in their own way, and they have their own engineers. That's a very big problem also. When you have data that is not structured, it takes a lot of time to actually aggregate and structure the data. And the worst, I think, is that it's not really connected to business development. So you're sitting in a meeting with managers, you actually don't know the data, the latest data that you have. How are you gonna make strategic decisions based on that to actually develop your business? And then there's this Brandon Bunk. He also has a very interesting blog post about how to approach an AI problem. I think it's very important, is that he suggests 3 conditions. First is that only use AI when you can prototype. Don't start with big problems that is not prototypable. So start with a prototype and iterate and fail. And then he says that you should not use AI to solve an entire system, but rather a specific problem. And the third example is pretty interesting, because he talks about Volvo. And he talks about the fact that use AI when you can actually make mistakes. Like Volvo's autonomous emergency braking, where they actually started that project way before the autonomous car, because that was a very specific problem. They can actually have mistakes. Okay, so far a lot of words, but let's get to more algorithms. There are 4 general types of algorithms questions you can ask when you work with machine learning. And I've make them simpler. They're usually called something else. It's like the first one is this A, B, C, or D? This is usually called a multi-label classification, but it boils down to this very simple question. The second one is how much or how many. That's a regression problem. You can only answer in a number. The third one is what we call an unsupervised learning, but that actually means how is this data structured? Basically, there's no question. Just give me something interesting about structures of the data. And the fourth one, what we call anomaly detection, is basically saying, is this weird? Is this transaction, this credit card transaction weird? That's anomaly detection. So there are only 4 types of question you actually can ask AI. For example, in sales and marketing, which of these 10% of my customers can get a offer? Or will this customer respond to a campaign? They are valid questions you can ask, like how likely is this person to make a purchase? Or in finance, is this credit card fraud, or does this applicant pose an acceptable credit risk? These are all valid questions. Or how likely is this person to make a purchase? You can actually answer these questions with those conditions that I talked about the data, with AI. So it's actually, since it's a general purpose technology, it actually can answer a lot of questions, which has a huge potential. But then the problem is that, okay, so we have the data and we have a question, then it boils down to the algorithm itself. This is my handwriting there. It's a Bayesian formula. But the problem is that what is machine learning? What is AI? Is very, very confusing to a lot of people. So my definition of machine learning is actually a curve fitting, meaning that I'll actually go to this, but it's about understanding the present and then predicting the future. For the present, you have data. For future, you don't. When you go to Facebook and you upload your photo, you expect it to tag you based on the pictures Facebook has seen. If Facebook's algorithm says, "Oh, I never seen you with an eyeglass," you would be like, "But you've seen me. Why can't you just imagine how am I with an eyeglass?" So this is how it works, understanding the present, predicting the future. But then how do we solve this? Is really three-step process. First, you have a data scientist and comes up with an idea of a model. And then that we call an outer loop, technically. And then we train the model. We show it examples of the data so that it finds patterns. And the third one is that we visualize and analyze. 3 steps. And it's iterative. So we come back again and again and again. There's no hard formula that we use. But then I thought, let's solve an AI problem together on the stage so that you see how it works. Okay, so I have a trend here, yeah? And using top-notch algorithms, neural networks, TensorFlow, all of that, let's see how we can actually find this trend. And I'm not going to go through the code, but we have published the code. So if you have a technical background, come talk to us about more details of how this works. So I'm feeding an AI algorithm, top-notch neural network, to find this trend. So it goes from -10 to 10, and it's actually an exponential polynomial. Every data will be powered to 3. So it looks like this. Before I start, I need to say that this is actually a hard problem for a neural network because of 3 conditions. First, this slope that you see is increasing very narrow. Neural networks like curves that are kind of edgy and they go up and down. This is very clever. This is very smooth. So they don't like it. And then the problem is that it only has 100 data points. So it doesn't have a lot of data. So they're against the favor of these algorithms. But let's try it anyway. And you know the way they work, these neural networks, is just with slopes. They see a curve and they walk through the slope. Okay, so this is solution 1. This is a neural network, 67 parameters, and then you see the error it makes. So the blue one was the trend, and what neural network found out was this red line. So it failed. Why? Because it's exactly what I said. The neural network thought that there's no slope because the slope is increasingly changing. So the neural network got fooled and predicted that this is just a line. This is a very bad model. That's why I call it solution 0. If you see this, then you just throw away your work. It has actually, the fun part is that it actually has 3 layers, and it has 8 neurons on the first layer, 2 and then 8. So it was supposed to work, but it didn't. And also, remember that this error is huge, it's 20,000 something, and this is because it's an exponential curve, so you get more penalty term by making mistakes. This is another failed solution. This time it has only 1 layer, and instead of predicting this, what it fails to understand is that it actually finds the slope. That's what I like about it, but what it fails to do is that actually trying to change sooner. It kind of gets stuck there and it stays on the same slope and comes up. And this is actually also 19 parameters. You know, the parameters are you can think of it as jigsaw puzzles. So when you have 19 parameters, you have to you have different ways of pulling them together. So it's, as this number increases, the neural network get more complicated. This one is very interesting. This one I like. This is a little bit bigger neural network. It has 2 and 4 neurons, 3 layers. It actually understands that the trend is going up, but what it fails to do is, again, the nonlinearity, or this curve. It doesn't get it, but it actually covers a lot of variance. And then this one is really funny because it actually half times it gets that there's some sort of curve and trend and then fails to do so on the second part. This is actually a bigger neural network. It has 3,624 parameters, but it still fails to understand this. And this is a time where data scientists go to their manager and say, can we buy GPUs? We need bigger models. We need to run them on GPUs. And then you think that it's going to solve the problem? No. Now we have 16,000 parameters in our model, and yet the result is almost the same. So it doesn't matter how many GPUs you have. You have a case that it's hard for the model to fit. So no matter how much you try in iterations, you're not going to get it. And then you have did I change it? Yeah. And this is huge. This is 4 layers. Look, 122 layers on first and second, and then 107. Still makes huge mistakes here. But if you're a data scientist, you should have already known that you can solve this really good with a neural network. You can actually fit this pretty beautifully with the Gaussian process. But what I wanted to show you here by these solutions and trial and error is that this is how the process works. And this is an iterative process. It takes a lot of time. It takes some time to train the model, come back, look at it, debate with other people, maybe we should change the model. And this is not an easy process. And there's no like hardcore definitions like, okay, this is what should I use. So this is kind of an exploratory territory, and it's very hard to walk in this space. But then the other question is that you saw here, that sometimes this error is pretty high, it's like 4 million. But then there are good things in the model that is trying to find trends. So what do we measure? Do we measure this number? Or do we measure actually the fact that it captures the trend? Do we measure how big it is or how small it is? And it's all there's no answer. Yeah, if you're running an AI algorithm for like a car and you want it to be very small to run on a chip, then you favor the small algorithms. If you want to work on the infrastructure is not a limit, then you work with big models. And the other thing is very important. I've seen a lot of people deploying models to productions, then they're not ready. When do we say the model is ready? When do I say as a data scientist to my manager, we can launch this to affect users? Yeah, and you all know about the bias and all those problems with models, right? First, when it actually can explain a fair share of users. Second is that it has an acceptable error. And those two are not really set in the stone. So you actually have to go back and forth to understand the dangers of running a model in production. Are a lot of people getting affected for better or worse? And how do we measure this? These are all soft measures in the process. So there'll always be trade-off. But I just forgot to say that so far it's not machine learning. What we're trying to do in machine learning is to predict the future. And that was not future. The model already has seen those points. That was not machine learning. So far it was just training. And this is the time that it actually needs to predict. So how well these models predict? They're not that good, but anyhow. Like this is the solution 2 that I picked that I liked. So these 2 points are supposed to be the things that the model hasn't seen. These ones model has seen, but they're on the same trend. So when you look as a human being, you say, okay, those 2 are in the same trend. So the model should have the ability to capture those 2, but look how far off it predicts. It predicts that, okay, those 2 points probably are around here. So then you have the test error. And this is the scary part, because you never know the observations, the data that comes into your model, you never know them. So when you launch the model outside, you always need to monitor this, because that's the machine learning part. But then the question is, if you don't have this case, that's the title of the talk, if you don't want to predict something, if you have a business and you want to find something in your data, I don't think AI is for you, unfortunately. So, and then the very important part of this, I think that you need to know that these observations, we have a lot of projects when the new data takes forever to get into the organization. And if you don't have this pipe, if you don't have observation, if you right now you work in a company and you don't know the sales as of right now, and you get the sale numbers in the evening, This delay means that your modeling is always behind. That's danger in modeling. Your model is not seeing the state of the art, the current data. So there will be always lags and like a lot of problems. But then if you don't have pipes, again, if you don't have pipes, then you don't have automatic cleaning of the data. This is the time when you have, because someone needs to go fetch the data, they always have these processes that are completely manual and they're against your favor. Yes. We started with a lot of focus since this January at iTeam to work with AI. We work with Stockholm AI, for example, a non-profit organization. This is a we think this is a very important thing, basically. And the way we work with AI is that we don't really work with AI in terms of like image recognition, cats and dogs, because I don't think that a lot of organizations are hungry for that type of application. What we keep talking about is a concept called data-driven decision making. It's a very elaborate term, and I really like it. It's actually a 7-step process that starts with framing and a hypothesis with data scientists and experts. And then in the second stage, you start to develop that hypothesis and collect data and analyze the data. The ML, the machine learning parts, are only these 2 steps. If you cannot use that to make decisions and communicate those decisions, then there's no point in doing all that to me. Then it would be a small like R&D project with no like hard values for the company. So it's a 7-step procedure. If you want to work with AI, you need to know it's a 7-step procedure. It's iterative and it's challenging, but the data-driven decision-making concept that we really like is actually trying to like put words on thoughts, basically. And one of the things that you really need to know is that the value of this process kind of exponentially grows, and you need to wait with it. If you start with collection, then there's like you spend a little time, get the data, then you don't have a lot of value. And analysis, yeah, you can kind of get some values, but you still hasn't connected this to the business development. And as you grow with interpretation, and that's what I mean by modeling part. And when you actually can connect this one to decision making is where it actually pays off. Make sense? So for this, we started working with like 3 packages that I like the naming of them. The first one is a skateboard. It was about to give you a fast way to go from A to B. And the second was a scooter. And the skateboard is just concept modeling, just like something like I showed you here with database exports with simple data. But for people that are very like, they're in need to actually get this some information about what they have. But then some people don't like to skate. If you're not a hipster, you don't want to skate, you want a scooter or something. So in the second package, we offer actually concept modeling and real-time pipelines. And in the much more elaborate package, we offer both production. And you can read it here in this the website we have. I guess that's all. Thank you.
Amazing, super interesting. So, har vi några frågor från publiken? Jag kan översätta om ni inte är bekväma med att fråga på engelska. Inga frågor? I have some questions actually.
Yeah, absolutely.
Yeah. The trend that we saw, is it based on an actual case of something?
Yes and no. This is how basically cancer grows with age.
Oh, really?
Yeah.
So that's what we saw?
Yeah, kind of.
Yeah.
But it wasn't like actual, but this is a very common thing that they grow like on polynomial trends. As you age, the chance of getting cancer grows like that, kind of. But my trend had like a backward trend as well. But that is not only the positive part that goes like this. That is actually, that a lot of trends in nature actually works like with polynomials. And it's like you can Google it.
Did you manage to solve it eventually? With AI?
Yeah, I solved it with another algorithm, not with neural networks. It's almost impossible.
Great. Okay. So you mentioned this seven-step procedure.
Yes.
Which part of that, or which step maybe, do you think is the most difficult ones for companies?
I think modeling, understanding modeling is the hardest.
And why is that?
Because it's hard for us to know that an algorithm actually doesn't really work. So you end up thinking that, okay, so you said you solve it and it would solve it in a week. But then you were like, yeah, but it has a lot of errors, so I need to find a better model. And I think that also like trying to explain that to decision makers is like a huge problem. Yeah.
Absolutely. How many models do you think you need to? Oh, we have a question.
Hi.
So how are you working with use cases?
So far, we have worked with 2 use cases. One was with Taxi Stockholm, and that was basically trying to predict customers going from point A to B, because that's not an easy problem, because it affects like a lot of factors take part, like weather, availability of drivers, and a lot of that. So that's one of the things we've worked with. The other was with Besedo, where we actually worked with like a recommendation engine for ads that people see. But if you're asking about how do you approach a use case, well, basically I think that right now approaching use cases is the hardest problem, because it's such a hard problem to actually translate that into the question. But if it's one of those questions that I saw, like I showed, it's pretty easy, because it's a solved problem, more or less, how to go from a question to a model. All data scientists know when a data science question comes in, what type of modeling should they use? The main question is that, does the customer have the data for it?
But then with your example here with a model, right? You said that was the hardest part.
Yes.
So what's the use case that you perceive you could apply for that?
Well, we had a lot of problems, for example, with the Taxi Stockholm case, for example. They had around 2 million data points that they wanted to model. But if you think about the Stockholm region and the chances of, like, you're standing on Teknikagatan, for example, at the first section or cross, and you want to go to a specific place. I mean, geographically it's very sparse, it's a huge space to cover. And 3 million data points for that region is not a lot of data. And they wanted to use a model, they wanted to model something, but the data, 3 million data points for that huge geographic part is not enough. And then getting data takes time. That data was like accumulated, I think, for 3 years. So you need to come back 3 years to have more data, basically.
So does this mean I'll get a cab exactly when I want in the future?
Hope so.
Do you think there's a problem that AI couldn't solve just a few years ago that now they can solve?
Anything regarding vision, photos, they're quite recent. Anything regarding vision, languages, and voice, sound. All of this would, when I wrote my thesis in 2013, you could not solve these problems.
Do you have a concrete example on any of these subjects?
Well, like now you have like Google Home that you talk to.
Yeah.
The models back then really could not understand. They were not as fast as the models now to actually hear you. So anything like a voice detection was almost impossible in that time.
And do you have a problem that you think we can't solve right now with AI, but that we will be able to solve in the future?
I think anything with like how to structure your data, like unsupervised learning, will be solved, because right now you don't have a lot of algorithms that actually can find structure in the data. I think that's the next big thing that will solve a lot of problems.
So what would that be, for instance?
They are working, right now they're working a lot with, at Google DeepMind, they're working a lot with new neural networks, but they're not the old neural networks. They call it conditional neural processes.
Okay.
And they are extremely good at give them a lot, like 100 points, like this, and they're very good at actually solving those problems. So
where you don't have a lot of data.
Exactly. So that's like, I would say, after talking to the researchers in Stockholm in ICML, I think that would be really the next big thing.
Amazing. Do we have any other questions? I think I saw some hands. No? Will you stay here so that
Yeah,
if someone
absolutely.
wants to
I'll be at
go
the
up
iTeams, what do you say, as well. Here and after that.
at the iTeams. Amazing. Thank you so much, Amir. Så himla intressant. Nu kommer vi ta lite mer än 5 minuters paus faktiskt, för vi höll tiden spot on. Vilket exempel. Vi kommer börja igen klockan 13:45. Då kommer SJ vara här och prata om hur de arbetade med AR, augmented reality, för att se till att trafikresenärer hittade rätt.